If you've ever experienced brain fog, you may have noticed something strange about the sensation. It doesn't just feel like your brain is tired, it feels like your brain is inflamed. And people describe it in a very specific way. Things like, my head feels swollen, or my head feels hot. It feels like there's pressure inside my skull. It feels like my thoughts are moving through syrup or mud. Sometimes there's this dull ache behind the eyes. Sometimes it feels like heavy weight sitting on the front of your head. And sometimes there's no pain at all. Just that overwhelming sense that your brain isn't working the way it should. Now here's where things get confusing. People go to the doctor, they explain these symptoms, they get blood work, maybe they even get scans, and everything comes back normal, which leads to this incredibly frustrating moment because the symptoms are real, the cognitive problems are real, but the tests don't show anything obvious. So people start asking themselves a very reasonable question. How can my brain feel this bad if nothing is wrong? Well, today I'm going to explain something that connects a lot of dots for people dealing with brain fog, chronic fatigue, Lyme disease, long COVID, and many other chronic inflammatory illnesses. Because many of these cases, the sensation in your brain is inflamed. It's actually the result of something happening deeper inside your physiology, something related to how the brain produces energy. Let's start with something important about the brain. Your brain is one of the most energy demanding organs in your body. Even though it only accounts for, say, 2% of your body weight, it consumes roughly 20% of the oxygen and energy your body produces. I mean, that's an enormous demand. That means your brain is extremely sensitive to anything that interferes with energy production. I mean, even small disruptions can affect how clearly you think. If neurons don't have enough energy, signal transmission just slows down. Communication between the brain regions becomes less efficient, and cognitive performance begins to decline. This is when people start noticing things like difficulty concentrating, forgetting simple words, losing track of conversations, reading the same sentence over and over, or just feeling like their brain simply won't fully turn on. But there's another sensation that often appears alongside these symptoms, the feeling of pressure or heaviness inside your head. And to understand where that's coming from, we need to talk about oxygen. Inside every cell in your body are these structures called mitochondria. I mean, mitochondria are responsible for producing energy, and they convert oxygen and nutrients into ATP, which is what your cells run on. Without ATP, cells can't perform their basic functions. Your muscles can't contract, your immune system can't respond effectively, your tissues can't repair themselves, and your brain can't maintain electrical signaling required for thinking and for memory. Now here's the key point. Mitochondria require oxygen to produce ATP efficiently, and when oxygen delivery drops, energy production drops. And when energy production drops, brain function begins to change. Things slow down. Focus becomes difficult, mental clarity fades, and the brain begins to feel different. Sometimes foggy, sometimes heavy, sometimes like it's inflamed. But oxygen delivery to the brain is more complicated than most people realize. It doesn't just depend on how much oxygen you breathe or how much oxygen is circulating in your bloodstream. It depends heavily on something called microcirculation. Your brain receives oxygen through an incredibly delicate network of microscopic blood vessels called capillaries. These tiny vessels, much smaller than a human hair, they play a critical role. They're where oxygen actually leaves the bloodstream and enters the tissue. Now here's where problems can begin. In many chronic illnesses, these tiny vessels become impaired. Inflammation can damage the lining of our blood vessels, something called endothelium. The endothelium control how the blood vessels dilate and contract. They regulate blood flow, and it's a major role in how oxygen moves from the bloodstream and into your tissues. Because when endothelial function becomes disrupted, blood flow becomes less efficient. Energy delivery becomes uneven. Certain areas of the brain receive less oxygen than they normally would. And when that happens, neurons begin to experience metabolic stress. When neurons begin to experience metabolic stress, several things happen. Energy production drops, neurotransmitter balance actually shifts, and communication between neurons just slows down. And the brain support cells become activated. These support cells are called glial cells. Glials actually act like the brain's maintenance crew. They're constantly monitoring our environment and our neurons, and when they detect stress or injury, they release signaling molecules designed to protect brain tissue. But these signals also influence how neurons communicate. They can slow certain neural pathways. They can alter our chemical signaling, and they can create the sensation that the brain is under pressure. This is why people often describe the brain fog as feeling like their brain is inflamed, not because the brain is literally swelling dramatically, but because the brain's internal environment has shifted to a stress response state. Now here's something interesting. A lot of people say brain fog feels exactly like a hangover, and that comparison is actually very revealing. Think about what happens when you have a hangover. Alcohol metabolism increases oxidative stress, inflammatory signaling goes through the roof, neurotransmitter balance shifts, and mitochondrial energy production temporarily drops. What's the result? It's slower thinking, poor focus, memory problems, mental fatigue. In other words, the same cognitive symptoms people describe with brain fog. The reason the sensations feel similar is the brain is experiencing similar metabolic stress. Not identical causes, of course, but similar disruptions in energy production. This is why brain fog shows up across so many different illnesses. We're talking Lyme disease, long COVID, chronic fatigue syndrome, autoimmune disorders, mold exposure, chronic inflammatory illness, all of these. At first glance, these conditions appear completely unrelated. They're different triggers, they're different diagnoses, there might be different treatments, but when you look deeper, many of them share the same exact biological pattern. We're talking inflammation, circulatory disruption, immune activation, and mitochondrial stress. Each of these factors can interfere with how efficiently the brain produces energy. Now, when several of them occur together, the brain begins to operate in a low energy state. And this low energy state produces many of the sensations people describe as brain inflammation. So before I continue, I want to mention something that connects closely to this topic, because when you start looking at chronic illness through the lens of oxygen delivery and mitochondrial energy, many symptoms begin to make more sense. We created a guide called The Synergistic Power of EWOT and Red Light Therapy. In the guide, we walk through how circulation, oxygen availability, and mitochondrial stimulation interact, and why supporting those systems together can influence cellular energy production. If you'd like to read the guide, there's a link below where you can download it. Now, there's another layer to this that many people don't understand. Your brain constantly monitors the body's energy supply. If the brain senses that energy production is dropping, it activates a protective response. That's fatigue, mental slowing, reduced motivation, and difficulty concentrating. These are not random, they're regulatory signals. Your brain is essentially telling the body, we need to conserve energy. This is very similar to what happens when your phone battery gets low. The phone enters this low power mode, right? Well, background processes shut down, your brightness on the screen drops, the system begins conserving resources. In many cases, brain fog is the neurological version of low power mode. The brain is trying to prevent the body from using more energy than it can produce. Now, this brings us to another really confusing experience many people have. They go to the doctor, they describe their symptoms, they get the blood work, and everything comes back normal, which leads to this frustrating question. How can I feel this bad and my tests look fine? The answer is actually really simple. Routine blood tests were never designed to detect metabolic and circulatory changes that produce brain fog. They measure markers floating in the bloodstream, but brain fog often originates from processes happening inside tissue, inside the cells, not the circulatory system. These processes rarely show up on standard lab panels, which means someone can feel terrible while their blood work still falls within normal ranges. Understanding that disconnect can be incredibly important because it shifts the conversation away from nothing's wrong, and that leads towards a much better question. What systems in my body might be limiting energy production in my brain? When you start to ask that question, many confusing symptoms begin to make sense. And that leads directly into this next video because brain fog itself is widely misunderstood. Most people think it's simply mental fatigue or stress or poor sleep, but brain fog actually has a very specific biological signature. And once you understand that mechanism, you'll also understand why it feels so much like a hangover. So if you want to understand what brain fog actually is and why it creates that strange hangover feeling, watch this next video. It's called What Brain Fog Actually Is and Why It Feels Like a Hangover. I hope you enjoyed this, and I'll catch you in the next one.